Hi everybody, we're going to be looking at the bus stop method of division today, which is a short division method. We're not going to go into long division in year 5. It's a short division method that's sort of like the equivalent of the column methods for addition and subtraction and multiplication. The only difference, well not the only difference, but the main difference with division is that you start from the left. So as you know, in column addition or subtraction or multiplication, you start with the ones or whatever digit is on the right, the smallest place value, and you work up to the largest place value. With the bus stop method, you start with the largest place value and you work down towards the smallest. So the calculation I want to look at is 635 divided by 5. I know that it will go exactly without a remainder. Just think to yourself, how do I know that? The reason we know is because we're dividing by 5 and the number ends in a 5 or a 0. So we know it will be a multiple of 5. So 5 will go in exactly. In division, the larger number that you are dividing into is called the dividend. And the number you're dividing by is called the divisor. So we have the dividend is 635 and the divisor is the 5. So before I show you bus stop, I want to show you why bus stop works. I want to show the mechanics behind it. So here I've got 635 and I'm dividing this by 5. Now, just to say, I ran out of ones counters. I didn't bring enough with me. So I want you to pretend that this whole pile is ones. I've got some other ones that aren't ones hidden in there, but I want you to imagine they're all ones. So I'm going to start on the left, as I said, and each of these is going to be divided by 5. So I want to see how many groups of 5 I can make out of my hundreds. So I've got one group of 5 there, and I haven't got enough to make another group of 5. So I know that I have one group of 5 in my hundreds. And of course, that isn't actually 5 at this point because they are hundreds. Now, what I'm going to do is move this into, I can't forget about it. I can't leave it there and not divide that as well. So I'm going to move it into my tens column. Now, to make it easier, I'm going to turn that into 10. So I'm going to exchange it. So here I've got 10 tens, which is the same as my 100. 10 tens are 100. So that has the same value as that counter there. So now I'm going to find out how many groups of 5 I can get here. So my tens I can split into 50 there, one group of 5 if you like, and 50 there. But I don't have enough here. So I've got 2 lots of 5 there. But of course, thinking of place value, again, they're not actually 5s. So I'm going to put a 2 here. And I've got these 3 left over, which I can't forget about. So I'm going to put those into my ones column. And what I'm going to do to make it easier again is exchange these 3 tens for ones. So 3 tens exchanging into ones. There's 1 lot of 10. There's 2 lots of 10s. And there's 3 lots of 10s. Okay, so that's what I'm now working with. And now I'm going to see how many 5s I can get out of this lot. So I know because those were 10 lots that I'll be able to get 2 lots there. This was 10 lots, so I'll be able to get 2 lots there. This was 10 lots, so I'll be able to get 2 lots there. And I had a 5 to start with. So I've got 1, 2, 3, 4, 5, 6, 7 lots of 5. So, bless me. So 635 divided by 5 is 127. Okay, so that's showing you how it works with the place value counters. What I'm now going to do is use this same calculation to show you how it would work with the bus stop method. And it's called the bus stop method because it sits inside a bus stop like this. You put the dividend inside, and I remember as dividend sounds like it's got the word in it, so it goes inside. And then outside the bus stop, you put the divisor, which is 5. Okay, I'm going to get another colour to help me with this. Now, what you need to do to help yourself, especially if it's a times table you're not confident with, is either have a times table square or write your times table out at the side to help you. I'm only going to go as far as 35. I know I'm not going to need more than 35. So I want to know how many 5s go into 6. Well, if I look here, it goes into 5, but it doesn't go as far as 10. So that means I can only get one lot. So up here, I know I can get one lot. So I've used 5 of those 6, which means I've got one left to go over here. And that's actually, of course, 100 that I'm moving across, or 10 10s. So now my 3 10s becomes 13 10s. So I'm going to look at how many times 5 goes into 13. So if I look here, I can get 5, I can get 10, I can't get as far as 15. So that means I've got 2. So I can write 2 above here. Oh, this pen's running out. There we go. Can you see that? Just about. I can put 2 there. Now, I used 10 of those 13 to make my 2 5s, which means I've got 3 10s left to take over to make that 35. Notice, like when you exchange in all the other calculations as well, it is exchanged as 3 10s. You don't add 3, so this doesn't become 8, it's 3 10s. So the 5 actually becomes 35. So let's look at how many times I can get 5 out of 35. 1, 2, 3, 4, 5, 6, 7. And it goes exactly. So then I put my 7 on the roof there. What we're going to do now is have a closer look at that bus stop method. To continue what you've just seen with the bus stop method of short division, we're going to start with a 3-digit number. And that number will be my dividend, don't forget. So I'm going to start with 912. And my divisor here is going to be 3. So what I'm looking at first of all is how many times my 3 goes into my 9. In other words, how many times 3 goes into 900. And because up here it will be the hundreds column, that does it for us automatically. It turns it into hundreds. Don't forget we start left to right. So to help myself out, I'm going to write out my 3 times table. I'm only going to go as far as that for now. If I need to add more later, I can. Okay, so I want to know how many times 3 goes into 9. Well, I can see that it does go exactly into 9, and it goes 3 times. So my quotient there is 3. There's nothing to exchange to here because I used everything. So I don't need to exchange everything. I used my whole 9. So now I want to know how many times 3 goes into 10. In other words, how many times 3 goes into 1. It will automatically be 10s because we're putting it in the 10s column. So I just need to think of it of how many times 3 goes into 1. Well, I can see over here, of course, that it doesn't, because the lowest number 3 goes into is 3. So I can put here a 0. But I can't forget about this 1. It's still got to be used. So I'm going to exchange it and put it here. And don't forget, that doesn't mean this becomes 3. You're exchanging a 10. So the 2 becomes 12, not 3. That would mean you're only exchanging a 1 and we're not exchanging a 10. So it becomes 12. So now we need to know how many times 3 goes into 12. Okay, let's have a look. 3, 6, 9, 12. It goes exactly 1, 2, 3, 4 times. So our quotient to 912 divided by 3 is 304. Okay, now that one I made sure it went exactly. I'm going to do a 4-digit number now. So my dividend is going to be 6,776. And my divisor is going to be 7. So it's a trickier times table. So I can either use a times table square or count in sevens and write out my 7 times table. My favourite numbers in it. Okay, I'll leave it there for now. I might need to go later. I might need to go higher than 56. Okay, so I'm looking at, first of all, how many times 7 goes into my 6. Of course, it's actually 6,000, but it will automatically do that as part of my answer. 7 doesn't go into 6 at all. It's too small. The smallest multiple is 7, apart from 0, but we're not using that one. So it's 0. It doesn't go into it at all, which means I've got all 6 of these that I haven't used yet. So all 6 need to be carried over to make 67. So I now know that my 56 down here isn't enough, so I've got to keep going. So the next one is 63, 70, 77, might as well go up to 12 times. Okay, so 67 I'm looking at. Well, if I go all the way through, 56, I can get to 63 I can get to, but not 70. So I can get as far as 63, and that's 9 times. So I'm going to put a 9 there. And then how many have I got left over? Well, I was on 63, and I've got to 67. So that's 64, 65, 66, 67. That's 4 that I didn't use. So that 4 is going to move over. So the number you exchange are however many you didn't use here, once you've got to the nearest multiple that's smaller than your divisor. It's got to be smaller, of course. So I've got 47 here. Let's have a look. I can get to 42, but I can't get to 49. That's too big. So 42 is 6 lots of 7. And 42, that leaves me with 43, 44, 45, 46, 47. That leaves me with 5 left over that I didn't use. So I'll take my 5 over. Now 56 goes exactly. That's 8 times. So my quotient of 6,776 divided by 7 is 968. Okay, now what I would like to try now is 8,407, and I'm going to divide that by 7. So again, I'm going to write out my 7 times table. This is good practice for my 7 times table. 42, 49, 56, 63, 70, 77, 84. Okay, so first of all we're looking at how many times 7 goes into 8. Well, it does go 1, but I still have 1 left over. I used 7 of that 8, but I've got 1 left over. Okay, how many times 7 goes into 14? Well, that's an exact number. That's brilliant. That's 2 times. I started writing the quotient in a different colour, haven't I? How many times does 7 go into 0? That's interesting. 7 goes into 0 times. But there's nothing to exchange because I actually used all that 0. So there's nothing to exchange there. So I'm still keeping 7 here, which of course goes into it once. So the quotient of 8,407 divided by 7 is 1,201. So I wanted to show you that one to show what happens when you get a 0 in your dividend. Okay, I would like to try now 5,205 divided by 5. Okay. Now I'm going to write out my 5 times tables. That's an easy one to write out. 35, 40. I'm going to leave it there for now. I can add more if I need to. Okay, 5s into 5, that's nice and easy. There's 1 5 and 5. 5s into 2, now of course that doesn't go, so that will be a 0, and that means I haven't used any of that 2, so I've got to carry the whole lot over. Now it's a nice and easy one to finish off. 5s into 20, that's exactly 4, and 5s into 5, there's a 1. So the quotient is 1041. Nice, easy one. Right, you might have noticed so far that everything we have done has gone exactly. So what we're going to look at now is what happens when they don't go exactly, when you have a remainder. So I'm going to try a smaller number for this. I'm going to do 6s into 75. Let's write out my 6 times table to help me. 24, 30, 36, 42, 48, 54, 60. Let's leave it there for now. Okay, so 6s into 7, first of all. Well, I can get 1 out, but I can't get 2. So 6s into 7 is 1. So that means I used 6 of those 7, and that means I've got 1 left to carry over. Now, 6s into 15. I can get 1 lot, I can get 2 lots. I can't get 3 lots. So I've got 2 there. But the answer's not 12 because there are still some here I didn't use. So I've got a remainder here. I've got a remainder of, well, I used 12 of those 15, so I've got a remainder of 3. Now in the past, I'm sure you would have just done remainder 3, but now we're in year 5, we can actually put it as a fraction. We can actually put that there are 3 of my 6 left over, so 3 over 6 left over. So that bottom number, the denominator it's called, is just your divisor. So your remainder is your top number, and then the bottom number is how many you've got left over. And some of you might know that 3 over 6 is actually equivalent to a half. So you could also say you've got 12 and a half there. So we've got 12, remainder 3/6. Not just 3. Try and put it as a fraction. Okay, let's have a look at a slightly bigger one to finish. I'm going to do 468 divided by 3. Let's write our 3 times table. 3, 6, 9, 12. Count with me. 15, 18, 21, 24, 27, 30, 33, 36. Okay, so we're looking at how many times 3 goes into 4. Goes in once. We can't get to 2. So my quotient there is 1. So I used 3 of those 4. That means I've got 1 left over to go here. How many times 3 goes into 16? 1, 2, 3, 4, 5. We can't get to 18. So we've used 15 of the 16. And that was 5 times. And we used 15 of the 16. So we've got 1 left to carry over. Now I was going to try and do a one with a remainder, and I didn't work out my number properly first, because what we've now got is an exact number, because we've now got 3s into 18, which does go exactly, and that is 6. So that was a good practice one, but it didn't have a remainder. Okay, I should have checked my number properly on that one. What you would notice, if I'd have checked properly, is that the digits add up to 18, and 1 and 8 make 9. And if you remember, if the digits add up to 3, 6 or 9, or in the 3 times table, they will be a multiple of 3, and I forgot to check that. So let's do one that I know won't work. 4,208 divided by 5. I know that won't work because it doesn't end in a 5 or a 0. Okay, 5, 10, 15, 20... Now, of course, a lot of you will be able to do this times table part in your head, but it is fine to write them out. It's not a problem at all. I'm going to stop at 50 for now. Right, 5s into 4. Nope, doesn't go. So that's a 0. That means all 4 of these haven't been used. So all 4 have got to be taken over to 42. Okay, let's see how far we can get. We can get all the way down to 40. We can't get to 45. So that's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 times, and we used 40 of the 42. So that means we've got 2 left over. Okay, that one goes exactly because it ends in a 0 4 times. And now we've got 5s into 8. Well, it goes once, but not 2. So we've got 1, and we've used 5 of them, 6, 7, 8. That's a remainder of 3. And if you remember, it's over your divisor. So it's 3 over 5, 3/5 left over. There is a way to turn these into decimals as well, but I'm not going to do that at the moment because that's a bit trickier. Okay, let's do a harder times table. 7s into, and we're going to make this the last one, 698. And I really hope that's not in the 7 times tables because I haven't checked. Okay, 7, 14, count with me, 21, 28, 35, my favourite number 42, 49, 56, 63 and 70. Let's stop there for now. Okay, 7s into 6. That's too small, it doesn't go. So there's 0. That means all 6 of these haven't been used. So we'll exchange them. Okay, 69. Well, that goes all the way through up to 63, but it doesn't quite get to 70. So that means I've used 9. It goes into it 9 times, sorry, and I've used 63 of them. So I've got left 64, 65, 66, 67, 68, 69. I've got 6 that I haven't used there. So I'm going to exchange 6. Okay, 7s into 68. Again, that goes all the way up to 9, but not quite to 10. So it's 9 again. And I've used 63 of my 68, because it's 63 is 9 times 7. So I've used 63, 64, 65, 66, 67, 68. I've got 5 left over, which means my remainder is 5 over 7. 5 over your divisor here. And remember the words, we've got dividend, divisor, quotient. All of that's the quotient. And to find the fraction, it's the remainder over the divisor. Okay, there's some work for you to have a go at now, so read the instructions on the classroom and find out what you're doing. Good luck.